So we're going to look at sketching some trigonometric functions. I've got two functions to sketch just up here, and I've got my reference basic trigonometric function graphs just here to help us out. Just to remind you, this is not something that necessarily you would be asked on an exam. However, it's a very useful skill to be able to visualize specific graphs and be able to sketch them very quickly, particularly if you were, say, asked to match up some graphs. Okay, we've already done a video where we looked at this particular function and we made a specific graph of it. This time we're going to do it very, very quickly, just a little sketch of it. Okay, this 2x, what does the 2 do in this function? Well, it's inside the sine function. Let's put some brackets in there just to clarify that. It's inside the sine function. So that is going to have an effect on the wave. This is a complete sine wave here. It goes 0 over to 2 pi. Well, with sine of 2x, what you would have is a sine wave going as far as the complete sine wave would appear by pi. So we can mark a point there. We're definitely going to have the end of our first wave there. So in actual fact, this sine 2x halves the length of the wave. Likewise, we've got this point at pi here. When we can put in that point, well, it's going to be at pi over 2. So let's mark that one in as well. Now, we've got those basic points, but remember we've got a point at 0, so we can put that one in as well. Right, so we've got those three basic points just to start us off. Now, what's this function going to look like because of the 3? Well, here on the sine wave, the regular sine wave, it goes from 0 up to 1, back down to 0, back down to -1. With 3 times that, it goes from 0 up to 3, back down to 0, back down to -3. So we can plot in a couple of points there, there, and there. And now, that's probably enough points for us to actually make a little sketch. That's all we need. And we know it's curved. It's going to look like this one. So remember, you can use your wrist if you like. It's very difficult for me to do that on the screen, but you could use your wrist on paper. It isn't a straight line, but you can make it as good as you can. Now, what's going to happen? Well, the sine wave is going to appear twice. Remember, it's sine 2x, so we've got to continue it out as far as 2 pi, but it's going to look the same. Let's just plot in those points just to be really clear about what that's going to look like. So, we're going to get this curve continuing on up to here, and then it's going to turn, come back down, and that's what your graph, your sketch of your graph of 3 sine 2x is going to look like. So we're going to continue on to this graph here. Y is equal to 2 cos 4x. Right, remember this 4 inside the trig function, what does it do? It's inside, so just put in the brackets just to clarify that as I did earlier. Cos 4x, what does it do? Well, it's going to squash up this. It's going to appear 4 times. This entire cos function is going to appear 4 times before it gets to 2 pi. That means by the time it gets to pi, it's going to appear twice. So the full thing is going to appear at pi over 2 once. Okay, now that's a really clear thing. You've got to be really conscious of that. The next thing to think about is, what does this 2 do? Well, we've got a little bit of a trick here. We've gone up to 4 here and down to -4 here. But is that actually correct? Okay, this 2 doubles the height. It doesn't quadruple it. Okay, so we've got to be clear about that as well. So this point here would appear here. Crossover point will be about there. And the other side of that will be here. We can put this top point there. And the bottom point is going to be down here. And now we can just make a little sketch of our graph. And it's going to look like this. And as I said, the cos 4x, it's going to appear 4 times, so we can just repeat that. We can just repeat our graph as we go. So let's just mark in the points that we need, just like this. So I'm just marking in the bottom of the function. We don't need necessarily to mark in all the points. We could just sketch them. And these will not appear if you're asked to match a graph. They won't appear. But it's always a good idea to plot a few points if you're going to match, if you're going to plot a function. So this is what your function will look like, and that is the graph of 2 cos 4x.